All right, so let's take a look at the solutions to the Git breakout session. All right, so the first thing, which I hope worked for everyone, was the git clone command. So it's basically just downloading all the code in the Git repository. Actually, I want to do that from a different directory. Okay, so if I do an ls, I've got this Bloom demo folder, so I'll cd into that. Take a look around. So first thing we should do is just take a look at the README. Okay. So this basically gives us some background on what this Bloom filter actually does. And since Git is all about workflow, I won't be showing you any slides. I'm actually just going to do the exercise for you, and you can sort of type along with me and see how many mistakes I make. All right, so let's take a look at the instructions. Okay, so the first thing we're supposed to do is to check out a new branch called work. So when you clone into a Git repo, the first thing I'd recommend doing is just doing a git log, and that basically gives you a succinct view of the commits, ordered in reverse chronological order. So basically, the most recent ones are at the top here. All right, so this was the last thing to be done before we cloned it. Okay, so basically, when we create a new branch, we're creating an identical view of the code base. So right now, we're on a branch called master. And then when we create a new branch called work, initially it's just going to have the same code in it. But then we'll change that and keep track of our changes. All right, so we can do git branch, and what that does is that lists all the branches there are, and right now there's just one. And then git branch with an argument will create a new branch. All right, so you see that there's two branches now. And then the asterisk tells you which branch you're on, which branch you're changing. So then git checkout lets us move to a different branch, work. Okay, so now we've switched to the work branch. And if we do git branch, the asterisk is moved. Okay, so all right, so then now on to question 3. Okay, so we're going to add a feature to the program indict that basically prints out the false positive rate. Okay. So let's take a look at the file. Okay. So an option is basically like a command line flag, and you can see that there's already an option to basically skip the things that are not, the words that are not in the dictionary. So I'll just run the example that's in the README. Okay, so that's without the option, and then running it with this -s basically removes all the things that are definitely not in the dictionary. All right, so now we want to add a function, an option to this file, to this program, which lets us print out the false positive rate. All right, so I'm basically just going to follow this template, going to define a new variable called, let's say, print fp, give it a different flag. And there's a more elegant way of passing flags at the command line, but we haven't got into that yet. So this is, as it says over here, the poor man's argument handling. Okay, and then I'm just going to make a small modification to what's being printed out. So I'll say, I'll define an out string, right? And basically reuse this piece of code over here. Okay, and then if this printfp variable is true, then I'm just going to append to this out string another string that says what the false positive probability was. And you can see that this is already defined over here. All right, so I've saved that. Thanks. All right, so let's see if that works. Okay, so when I set the F flag, I'm getting a false positive probability, although it doesn't make much sense because it's negative. And when the F isn't there, then it's working just as normal. So at least setting the option seems to be working, okay? All right, so all right, let's go back to the instructions. Okay. Okay, so yeah, so as we saw over here, there's a bug. It's giving us negative probabilities. So we have to find this bug. And that's going to be in this Python file. And let's see. Since I did this already, there we go. So Josh had a little spirit vision. We're gonna remove this bug. And what you initially might be tempted to do if you're making a change to a code is do something like that. And I've worked with code that has a lot of that. And this sort of runs against like the philosophy of Git. And Git's a beautiful tool. And what it lets you do is just be okay with deleting code, right? Because it's not going away. You're keeping track of everything you do. So let's get rid of all of that, all right? It's okay. All right, so we've saved that. Okay, and finally, we're going to look at the README and just bump up the version number, all right? And also document our changes. So, -f prints out false positive rate. Okay. Okay, so now we're going to commit these changes, okay? So every commit involves typing git add something and then git commit. Okay, so basically adding it lets Git know that you're ready to commit something, that you want to, that you're letting it know which files that you're telling it to track, and then git commit actually lets you write a message and actually commits those files in. So it's a two-step process. A handy command is git status, right? And it shows you that since the last commit, all right, so since we made the second branch called work, there are 3 modified files in there, the readme, bloom.py, and indic. All right, so the first commit is the commit fixing the bug in the false positive rate. So that was in bloom.py, so we're going to do git add bloom.py. Okay, let's take a look at what happened to git status. Okay, so you see that the output of that changed a little bit. So it says changes to be committed. Okay, so we've added that. So now if we commit, it's going to basically track the changes on bloom.py, but these other things are changed but not updated. So if we were to commit that, these things would still be modified and untracked. All right, so let's commit that. Just git commit. What that does is it pops me into an editor. This is just the terminal version of Emacs. And I'm going to just write a little message saying what we did. So we fixed, Josh's spirit vision. Okay, we're gonna exit out of that, and it automatically. One of many. We fixed one of many spirit visions. Well, yeah, we haven't tested it yet. That's a good point. All right, there we go. So, all right, thanks. So that actually might have been a good example if we hadn't to show git amend. Okay, so all right, so now we want to do another commit. But before I do that, I want to show you how to use this git diff, right? So we've made a commit, and if we want to see what the difference is between where we are now and the last commit, we can run this command called git diff. And basically this shows the difference between the current version of the files, right, as they are in my directory, and what they were at the last commit. Okay? So you can see that it's a little hard to read at first, but it's telling you that the README has changed, right? And this minus tells you that I've deleted this line with minus, and the plus tells you that you've replaced it with this. And then also there should be this indict has also been changed. Okay, and I actually find that a nicer way to look at this is with color words. Because it sort of gives you a more Wikipedia-style representation of the changes. So basically, red things are deletions, green things are additions, and then white things have been unchanged, but Git includes that for some context. All right, so this is a good way to see so git diff with no arguments tells you the difference between what you've got in your current directory and the last commit. You can get a little fancier if you want to take a look at the difference between two commits that are anywhere in the log, right? So we can look at the difference between, let's say, this commit and that commit. And you just need to specify them by the SHA, and you don't actually need to type in all of these characters. You can usually do it with just a couple. All right, so basically what this is telling you is that the only difference between those two commits was the change in the spirit vision. So I deleted all of this text. Okay, so let's go through and add and commit. So let's add the change that we made to the README. All right, so git status says that we've modified the README and it's ready to go in. Here's sort of a nice little shortcut. This git commit -m. A lot of the times your commits are fairly minor, and you can just say them with one line. So this could be updated README, something like that. All right. So I wasn't passed into an editor. I just did that with one line on the command line. And then finally, the last thing that we want to add is the change to indict. And so the last thing, the last sort of shortcut I'll show you is git commit -a. Basically says take everything everything that's modified and not added, add it, and then commit. Okay, so if you have a lot of things that you need to add, you can just run with this, and then this -m lets you do the shorthand form of the message. Okay, so actually, so the modification to indict was actually different from the version number. Okay, so new option in indict. Okay, all right. So we've made all the changes. So git status says nothing to commit. Everything is up to date. And so the last thing we want to do is merge the changes we've made in the work branch back onto the master branch. So how do we go back to the master branch? Yep. So master, all right, so that command wanted to create a new branch named master, and it complained because there was one that was, yeah, exactly. Okay. All right, on branch master. So then we can just do git merge work. So what that's going to do is we're here. We're on master. This is where we are right now. Work has moved ahead by several commits. And basically what we want to do is basically merge in all of those commits and basically fast forward master so that it's all the way up here. Okay, so we've done that, and then it gives sort of a little summary of the changes. So I think what this means is we've modified 5 lines and we've added 4 and subtracted 1, something like that. Okay, and I guess the last thing we want to do is tag it. Git tag.
You want to show what the branches are now?
Like that?
Yeah.
Okay. So one thing actually that that exists are these nice sort of GUIs for visualizing your Git commit tree. And here's one that just came with my version of Git. I'm not going to pretend that it's great, but what it tells you is basically it shows you where you are, and it gives you a little summary of the previous commits, and then also the diffs between each commit and the previous one. So we'll sort of let you visualize. And if you've got many trees, you can imagine that this structure over here could become fairly complicated. Okay, and I actually forgot how to tag stuff. So does anyone want to give me some help? Ah. Okay, let's see. So, all right. So I'm guessing it's git help tag. All right, and then all right. So you can see that this tag has been added to the current.
So just a little addition. If you use a -A for the git tag command, it's what's called an annotated tag. So it will actually annotate with the author and the time, which is usually what you want. So what you did here is a kind of a lightweight tag. So it just kind of creates a tag quickly. But if you want to have a version release, you usually do an annotated tag.
Okay.
So basically, you can think about it. It's the same shortcuts that you do with commit. Is -A for annotated and -M to create a message on that annotated.
Okay. Yeah, I hadn't actually seen tag before today.
So what's the purpose of the tag?
Purpose? It's basically just putting a label on the state that you're in. So you say, okay, now this is something that this is a milestone for my software. I want to give it a release name, or I want to say something about that. And then you can always go back and check that out. So imagine that after 2 years, you still think that version 1 was better. You can actually go back to version 1. You don't have to figure out which commits was it that corresponded to version 1.
Yeah.
If you merge them, why does it still say up there that your branch is ahead of master by 3 commits? Origin.
So origin master refers to the branch that's on GitHub, right? So we cloned that repo. So yeah, so that version of master on origin is still behind us. So we would have to push. We'd have to push to the Git repo on GitHub to make that one come up, up toward our current branch.
So, do we want to delete this work branch, or just start working there tomorrow, or what?
Yeah. So the question was, do you want to delete? Do you want to delete a branch? And that's kind of that's sort of up to you. But if you're not going to be doing any more work in that, then there's no harm in deleting it. All the changes were passed on to master, so there's nothing sort of unique in work anymore. So I think use git help branch. So I think, let's see, this -d means delete the branch name. So git branch d work. Okay, so I deleted that. So now git branch just shows master.
Now, how do we go back if we realize that the spirit vision was correct? How do we go back?
Okay, so the question was, yeah. So how do we go back if we realize that that we made a bad commit? So basically, sort of going to a specific branch, you always basically call git checkout. That basically brings you back to the version, at that specific commit. So let's do a git log. All right, so we fixed Josh's spirit vision. So then let's go to the one before that. So we'll copy the first part of the SHA. Then we can do git checkout. Okay. So now if we open up that file again, yeah. So you can see that this code has reappeared. We're at exactly the same state as we were before we made the commit where I said that I fixed it.
So if we want to make that the new stable spot, we should recommit the checkout?
Yeah, so let's see. So I think what we would want to do is basically follow this over here. So I don't know. Let's call this spirit. Yeah. So what git checkout /b spirit did was it basically said create a branch called spirit and then check out that branch. So now if I do git status, it says I'm on branch spirit. Git branch should say that there are two. I'm on spirit, and now we can start going and making new improvements to spirit vision.
But you could move over to master and then merge spirit into master. But the problem with that is that you have all the new changes. Sorry, spirit doesn't know about the changes you made after spirit, because you're pointing to the first sort of hack that you did. But if you now did a merge, that would give you back exactly what you want. Right? You've got all the other changes to the other files, but you've got this spirit vision back in.
So let's take a look at this sort of representation over here. So it basically says that we've moved back in the tree. And then if I switch to master, all right, and then I update this. All right, so you see that we switched and we moved forward by 3 commits. Okay, so we can basically just go back and forth. And if these two things diverged, you would see these two branches sort of split off. And then, you'd be hopping back and forth, on these leaves.
Now we have to want to merge master with spirit. And have to bring that to do it version. Is that what happened?
Yeah. So if you wanted to merge, all right, so let's move into spirit. Okay, and then git merge master. Okay, so that basically applied the same 3 commits on top of Spirit. And then if I update that, you see that the current leaf is, we're on Spirit. But that version of Spirit now is the same as the latest release of Master. So they're essentially the same code base at this point.
We've now gotten rid of the Spirit vision.
No, that's still around, but we've updated all of the changes that we made since we deleted the Spirit vision. So none of these commits have been lost anywhere. I could easily just go back and do the same exercise again, where I went back, I checked out that old commit, then I created a new branch, and done more work on that branch.
Is there a way to just check out an older version of one file from, say, an older commit?
Yeah. So I believe the way to do that. Let's check out that Spirit vision. All right. So we want to check out this commit. So git check out. That's the commit, and then the file was bloom.py. Okay, so right now I've pulled over a specific file from that older commit, and then if I take a look at that file, it's got the Spirit vision in it.
Or if show.
So yeah, so basically I've modified bloom.py. I've basically put the Spirit vision back in effectively. So git diff, then I'll do the color words.
Because it's staged.
Do cache. Minus cache.
My dash cache.
Cache.
Okay. So that's because I haven't staged bloom.py yet, or what?
No, you did stage it.
Oh, okay. All right.
If you see it says up there, it says changes to be committed, and that's where it listed as modified.
Okay.
So it was already staged for you when you did the checkout.
Okay.
So just a couple more things to say about Git, and then we'll do the homework. Maybe. Here's GitHub. Here's me logged into GitHub. And the nice thing is you can see all the different repositories that you're following and sort of more or less a stream of what's happening in those repositories. And the thing that we can tell you now, not that we were really hiding it, is that there's a public repository called Python Bootcamp. And this has all of the edits and all of the additions that we've been making as counselors over the last week or so. And you can see as we're all basically different people are committing, you'll wind up seeing all the different, you'll see all the different names here. And I can see what Barion's done and get to his homepage. Here, Isaac is the one who did the last commit. I can look at the data files, not be math files, data.txt. So GitHub knows how to render certain types of files for you nicely. In particular, it's pretty good at rendering Python files and makes it nice and pretty. And you can look at the history of that. That's a pretty boring history because I haven't changed much. I just added it once. But if we were constantly changing that, you'd see it. There's the thing about blame. If I actually just want the raw data, I can link to that. It doesn't yet know how to mark up IPython notebooks, but that NB viewer thing is sort of a starting point here. So here you see this is essentially just JSON. for those that are comfortable and familiar with that. But it's a pretty nice environment to work in. And you can even see that it knows how to render Markdown, which is basically how we worked on the schedule. And people can change their name, change what they're willing to work on and things like that. And we basically did all of our development of the bootcamp within GitHub in a public way. So we weren't blaming each other for too many things. We can take a look at how this all wound up getting developed over time. This is a calendar essentially up here, and I can scroll around. And what you see here are these different, should be able to, it should pop up and show me. There we go. So here Henrik did some merge. I merged some branch back onto the main branch. And you can see all the different commits that people are making over time. And here's where we are now at the master. So it's a pretty nice way to follow the development of, in this case, we're not really developing a large code. We're developing the class, right? And now that this is public, anyone else, when they find out about this, will be able to fork this repository, make changes, do whatever they want. And there's only certain people who I have, because I created this, who I have given access to basically be able to commit. If somebody actually wanted to commit something and they didn't have that access, they could issue a pull request. I could look at that stuff and I could make a decision whether I want to pull that in or not.
They can still commit locally if they want to push something.
Sorry? Oh, sorry. Yeah, they can commit locally. They can build an entire other thing, and eventually it'll become a Perl bootcamp, right? And they'll reuse all of our slides, and they'll just take all the Python out. And then they're going to say, I want to merge this into the Python bootcamp, and I'll say, absolutely not, right? But then they'll just have their own repository, and now they've got something which is just totally different. But they will retain the full history of how everything got developed. So you can see we've got open repositories. I have a couple closed repositories, like for writing a paper, and I just want to have a place to push this to, and I've got a few other collaborators, and I want everyone to see all my dirty laundry, but I do want to keep all my version history. That's a totally fine way to go about it.
You have a question?
Yeah, is there a question? Yes.
So all the current versions from Bootcamp, are they pushed to the agenda website?
What's that?
All the current versions in Bootcamp on GitHub, are they all pushed to the agenda page?
Yeah, so basically if you notice, if you just mouse over a lot of those links, a lot of them are just pointing back to the GitHub. And so like all the notebooks, as soon as I update a notebook, effectively the agenda page is updated without us having to do anything. You generally think about pushing files like Python files and scripts and maybe a couple of text files over. I've been pushing over Keynote files, which are basically binary files, pushing over PDFs. That's generally, I would say, frowned upon to be sort of polluting your repository with binary files, because if somebody wants to clone it, it's going to be like a 100 meg directory because it's a lot of binary stuff. It's not illegal. It's still open and free, so anyone can use it. But generally what you wind up doing with Git is that you more or less think about it as sort of committing more or less code that you're writing. Or if you're writing LaTeX or something, you commit that. But once you start committing large amounts of binary files, that's not usually a good idea. You usually want to sort of point off to another place where that data might live. I felt like we had just a few enough number of PDFs and Keynote files that it would be okay to put it in there, and no one would get too upset about it. So GitHub has as their mascot something called Octocat, and there's lots of different incarnations of Octocat, which you can get at here. Octodex. Their artists are apparently paid way too much and have way too much free time. Somewhere on here, there's an Obama version of the Octocat. There it is. Yes, we code. So now you know where that comes from. And there's the Tron version of that as well. It's a pretty cool company, and they're, as I think Henrik said, they're kind of doing great things for sort of development in general. So we're hoping that all of you will wind up adopting Git, but then many of you, if you are able to work in an open environment,
will use something like GitHub. And they're not paying us that much to say stuff like this, just in case. Okay, so let's take a look at the homework. Were there any other questions about Git? No? Okay. So homework 2 is essentially a simulation. It's a Monte Carlo simulation. And when in Monte Carlo, you should be thinking about money. So we have a question, basically. And we have this notion that we walk around all day. We pay for stuff with cash. And if you have credit cards and you have debit cards, you just pay with that. But in the olden days, we used to walk around and we used to have cash in our pockets, and we used to pay for stuff. And the probability that you have to pay exactly $1, exactly $5 is obviously pretty small, especially if you go to the supermarket. You more or less have a random chance of the final bill being between 0 and 99 cents with some integer offset from that, right? So the question we want to know is, at the end of the day, after you've paid with X number of transactions, how much change are you accumulating? And now we want to know how much change are you accumulating, say, at the end of the year. And I want to know the distribution of coins in your money jar at the end. So we have a couple of different ways in which we set up this problem. And you'll be essentially implementing this. And obviously, we want you to think about this in an object-oriented way. You make X purchases each day with petty cash, starting out with only bills in your pocket. That is, you start off with lots of bills, you've got no change in your pocket. Each purchase has a random chance of costing some dollar amount plus YY cents, where YY goes from 0 to 99. You always get change in the smallest number of coins possible. For instance, if you have a purchase for $2.34, then you assume you acquire 66 cents in change, and the smallest number of coins that you can get back for that is 2 quarters, 1 dime, 1 nickel, and 1 penny. If you have enough change to cover the YY cents of the current transaction in your pocket, because you're accumulating that throughout the day, you use it. Otherwise, you accumulate more change. For example, if you have $1.02 in loose change and you have a purchase of $10.34, then you use 34 cents, or as close as possible, in coins, leaving you with 68 cents. We're not being exact about how to do this in all the edge cases, so you'll have to figure out how you want to implement this. At the end of the day, you dump all the coins that you collected in the day into your money jar. Here are the questions that we can now ask once you set up the simulation. What is the average amount of change accumulated each year, assuming X equals 5? That is, you have 5 transactions a day. What's the 1 sigma scatter about this quantity? So you're basically going to run many, many iterations of this where you're setting X equals 5. And because you have a random number generator as part of all this, that is how many, what's the value of the transaction that you're doing, where you're doing 5 transactions, you're not always going to have the same amount at the end of the year, right? And so we want to know, what is the total amount of change that you've accumulated, and what is sort of the scatter about that? If you think of this as a normal distribution, this is the 1 sigma. This is sort of what encapsulates 68% of all the trials that you make. What coin, quarter, dime, nickel, or penny, are you most likely to accumulate over time? What's the second most likely? And does your answer depend upon X? So if I only do 1 transaction a day, do I get a different answer for the total number of coins that I have than if I do 10 transactions a day? And you can choose a couple of different X's to try to figure this out. I thought this was a very interesting question. I always want to know this answer. When you're a professor, you want to know something, you just assign it. And then you hope somebody comes up with an elegant solution to it. Let's say you need 8 quarters per week to do laundry. How many quarters do you have at the end of the year? If you don't have enough quarters at the end of each week, use only what you have. So effectively, you go each week now, not every day, but you now look in your cookie jar or your money jar and you say, how many quarters do I need? I need 8. You pull those out. So you're draining your quarters on a weekly basis. Okay, so here's how we think this might happen. Write a class called cookie jar that knows how many coins it has inside, how many transactions is completed, how long it has been filled for, etc. You might write a function which takes an input transaction amount and returns a total number of coins as change in a dictionary. For example, if I said calc change 3.45, that means that I have to generate 55 cents in change, and so you need to go through the logic to figure out how many coins you're getting back. In your run, you might instantiate the cookie jar and have its run method perform all the transactions for 1 year, and maybe you do this 50 times so you can get a good sense of the spread of the results. This will take a little while to run, and it'll take a little while to code, but that's why you have tonight. I told you it was going to be painful. Any questions about sort of the setup and how you might go about this? Everyone's got it? Is it interesting enough to keep you motivated to write object-oriented code? Sort of. The winner gets a quarter.
Are there particular advantages to doing it object-oriented in something like this when you only have one instance of a cookie jar?
Well, there's one which we won't really show you how to do for tonight, but you'll see tomorrow, is that you could run 50 parallel instances of a cookie jar. So you could run it over multiple cores on your computer, right? So if you've got 8 cores, you could use all cores to run as many cookie jars as you can per year. If you want to go outside of your computer, you can use all the great parallelism that's exposed to you in IPython and run it on an Amazon Web instance, or Amazon Web thing, right? So you could actually spin up a whole bunch of computers, and you just ask this 50 times, and with the same exact parameters, pull back the results, and do that. You don't have to do this in an object-oriented way, but the idea that you've got a bunch of transactions, you're saving the results into those transactions, makes sense that the sort of atom of what it is that you're carrying around is actually the physical thing that you're carrying around, which is the cookie jar. You could go even more atomized from that and talk about, an object being in your pocket, right? And what's inside of your pocket. That's much more of a container. But the idea that you as a person are walking around and you're doing transactions, think of a transaction as a method that essentially operates effectively on the cookie jar, right? Yes?
The way it's originally written, it says you dump the change into the cookie jar at the end of the day, so you also need a pocket class.
You could do it, yeah. I'm not trying to say there's only one class, but I was thinking of cookie jar as perhaps the base class. Yeah. You could imagine pocket as a subclass of a cookie jar. Any other questions? So we'll be around for a little bit now if people want to start coding. And then tonight, some of us will try to be on the IRC channel. If you need help immediately and you're not getting it, just send us an email, and we'll also try to respond to that very quickly. We'll see you all tomorrow.
Called work. So when you clone into a Git repo, the first thing I'd recommend doing is just doing a Git log, and that basically gives you a succinct view of the commits, ordered in reverse chronological order. So basically, the most recent ones are at the top here. All right. So this was the last thing to be done before we cloned it. Okay. So basically, when we create a new branch, we're creating an identical view of the code base. So right now, we're on a branch called master. And then when we create a new branch called work, initially it's just going to have the same code in it. But then we'll change that and keep track of our changes. All right. So we can do git branch, and what that does is that lists all the branches there are, and right now there's just one. And then git branch with an argument will create a new branch. All right, so you see that there's 2 branches now. And then the asterisk tells you which branch you're on, which branch you're changing. So then git checkout lets us move define over here. All right, so I've saved that. Thanks. All right, so let's see if that works. Okay, so when I set the F flag, I'm getting a false positive probability. although it doesn't make much sense because it's negative. And when the f isn't there, then it's working just as normal. So at least setting the option seems to be working. Okay? All right. So all right, let's go back to the instructions. Okay. Okay, so yeah, so as we saw over here, there's a bug. It's giving us negative probabilities. So we have to find this bug. And that's going to be in this Python file. And let's see. Since I did this already, there we go. So Josh had a little spirit vision. We're gonna remove this bug. And what you initially might be tempted to do, iterate. Right? So I'm basically just gonna follow this template, gonna define a new variable called, let's say, print fp. Give it a different flag. And there's a more elegant way of passing flags at the command line, but we haven't got into that yet. So this is, as it says over here, the poor man's argument handling. Okay, and then I'm just going to make a small modification to what's being printed out. So I'll say, I'll define an out string, right? And basically reuse this piece of code over here. Okay, and then if this printfp variable is true, then I'm just going to append to this out string another string that says what the false positive probability was. And you can see that this is already... All right, so let's take a look at the solutions to the Git breakout session. All right, so the first thing, which I hope worked for everyone, was the git clone command. So it's basically just downloading all the code in the Git repository. Actually, I want to do that from a different directory. Okay, so if I do an ls, I've got this Bloom demo folder, so I'll cd into that. Take a look around. So first thing we should do is just take a look at the README. Okay. So this basically gives us some background on what this Bloom filter actually does. And since Git is all about workflow, I won't be showing you any slides. I'm actually just going to do the exercise for you, and you can sort of type along with me and see how many mistakes I make. All right, so let's take a look at the instructions. Okay, so the first thing we're supposed to do is to check out a new branch to a different branch, work. Okay, so now we've switched to the work branch. And if we do git branch, the asterisk is moved. Okay, so all right, so then now on to question 3. Okay, so we're going to add a feature to the program indict that basically prints out the false positive rate. Okay, so let's take a look at the file. Okay, so an option is basically like a command line flag, and you can see that there's already an option to basically skip the things that are not, the words that are not in the dictionary. So I'll just run the example that's in the README. Okay, so that's without the option, and then running it with this -s basically removes all the things that are definitely not in the dictionary. All right, so now we want to add a function, an option to this file, to this program, which lets us print out the false positive